Hi guys. I've been in the market for a CNC milling machine for a while and I finally found a decent deal on one. This is a Tree Journeyman 325. This has travels of 27-inch on the x-axis, 14-inch Y, and 6-inch on the z-axis. It's a pretty heavy machine, weighs about 4,600 pounds. It was an interesting adventure getting it here. It's kind of stuck on this pallet at the moment. Eventually I'm going to move it, probably put it on a rolling platform so it can be moved around. I've got some high-load casters for that. I've got to go get some heavy metal so I can put it and then figure out how to get this frame under it. But then I'll probably turn the machine 90 degrees and push it back into this corner back here where these shelves are right now. And that seems to be the best way to put it kind of constrained for space in here. This is a 1986 vintage machine, same age as I am. It has a Dynapath System 20 control. From what I'm reading, this is a pretty decent control. Reasonably fast to respond, pretty easy to work. This machine has a Cat 40 tool holder with quick release. It has a pneumatic system to release the tool. I don't have the compressed air connected up, but I should be able to show that later. The machine is in pretty good working condition. All the basic functions work properly. All the axes work. X-axis, Y-axis, and Z. Oh, hit the stop there. The backlash in the ball screws isn't too bad. The X-axis has about 0.7 thou, the Y-axis has about 2.2 thou. I think the Y-axis could do with to have new balls put in the ball screw. I'm concerned about the X, and I can't measure any backlash at all in the Z-axis. The problems I have found, sometimes when doing rapid moves, if you put it on rapid mode, it will, servo drive will sometimes error out, although it doesn't seem to be doing it now after it's warmed up. Maybe if we do multiple axes at once, if it'll allow you to do that. Yep, there it did it. And I've been measuring some of the voltage on the servo amp power supply, and it seems to be a little bit low. So I'm thinking either it's a bad capacitor or just the line voltage is low. The other problem I've been having is when trying to run programs, it'll stop in the middle of the program after a rapid move. And I've done a bit of research on that, and it seems to be due to the servo drive not being balanced properly. It's somewhat difficult to get into this cabinet here, but I've got the multimeter connected up to the main filter cap coming on the servo power supply, and this is running at, what do we have, around 96 volts, and from what I've been reading, these should be running at a bit over 100 volts, so it's a little bit low, and when we move the axes that drops even further. But again, looking in here, we have 3-axis servo drives on the left. You can see some big old TO3 transistors on those. It definitely shows its age. Control transformer for the 120 volt system, the control system, the display, and the CNC controller, and some relays, some inductors up there to reduce increase the inductance of the servo motors. You can hear the switching frequency you should be able to hear it. It's probably around 5 kilohertz or so. So they had to add inductors over there. Anyway, let's just try moving the axes again while watching this voltage. Yeah, it definitely drops when you move the axis around, and when you stop moving it, it goes up, probably from the when the servo motor operates as a brake, it's regenerative, so it recharges the bus slightly. I think there's a resistor on the bus to pull that voltage back down. See if we can do that simultaneous move again. Yeah, just approaching 91 volts. Yeah, I may have to check that power supply. Basically, this capacitor is fed directly by on the bottom of this, there's a large transformer, a 3 kVA 240 to 70 volt, and that 70 volts is rectified and filtered and produces something around 90 to 100 volts. And That seems to be a little bit low. I think, for as far as I can tell, the output of that power supply goes directly to the servo amps. There's no regulation on it at all. It's just the rectified and filtered output from this transformer. I'm also going to probably have to move this transformer because it'll get in the way of the frame I want to build to move this. What I'm planning to do is have something that goes under the machine, comes up and over, and the caster will be over on the side, so the machine is very close to the ground. So I don't want to have it much higher up. It makes it more stable as well. There's a pretty nice aluminum table on this machine with lots of half-inch tapped holes. It's really heavy. I think this aluminum piece alone weighs about 40 kilograms. And of course that's just bolted onto the regular table. What else do we have? On this side, assuming we have the automatic oiler. It seems to be working because this piston was lower down earlier, and what it seems to do is it pulls it up, and a spring slowly pushes it down and slowly forces oil down the tube onto all the lubrication points. Yeah, here's the X-axis ball screw. Looks pretty good. Up here we have this part of a coolant misting system, or what's left of it. This doesn't seem to be in very good condition. I'm probably just going to replace it with a whole new one. I think it's had some sort of a control to turn it on and off from the main system control. On the back, this box has the motor, the spindle drive. The inside here, I don't know, it's going to be difficult. We might be able to see this. Let me see if I can get in there with a light. Okay, inside the column, on the bottom we have there's a pump for the coolant. I think it's a whole bunch of oil down in there right now. We'll have to open up the drain plug and get that out. And let's see, let me turn this around. Up in the top, there's the spindle motor. There's a cooling fan on it, I think. As far as I can, from the documentation, this is an 8,000 RPM motor, and there's a belt drive over the top of the machine up here, from this side over to there, that drives the main spindle. And this one has the 3,500 RPM option, so it's a slight reduction. You can also get a different pulley to install on this to get an 6,000 RPM spindle, which I think might be useful since I'm going to be doing a lot of small milling, or milling on the small end mills on aluminum. In the back box here, there's a VFD to drive the motor. There's no adjustable gearing or anything on this, and a bunch of contactors. Another reason I want to put this on wheels is so that I can back this thing up against a wall to get the most amount of space in the garage here. And then to get into this rear box, we'd have to back the machine away from the wall so you can open it. And I know this is not the best solution, but there's compromises when you have to fit it in such a tight space. Down on the bottom here, there's some air filters for the compressed air system for the drawbar, and just a bunch of wiring. The air filter is a bit leaky right now, but I think I can run the drawbar for a short while. I'm just going to lower this just in case the thing drops the tool when I put the air in. Put it all the way down, and then raise the Z-axis. Actually, probably that's close. Let's put something underneath it so it doesn't damage the tool. There. There we go. Yeah, the filter is leaking pretty badly. I'll have to replace that, but I think we should be able to operate this. Okay, take that back up. Should be able to. Yep. Nice quick tool changes on this. And it's nice that the tool is held in by a spring rather than compressed air, so if you lose your air supply, the tool doesn't fall out, which could be quite dangerous. Oh yeah, the other problem is the handle broke off when this was being shipped to the previous owner. I've got to weld this back on. Okay, let's see if we can fix this rapid move problem, or where it stops after a rapid move. So from the stuff I've been reading on the Practical Machinist forums, we have to go to Setup menu and put it in TM4 servo adjust. So TM4, I don't like the non-QWERTY layout, but it'll have to do. Press enter. Then we go to mode select, or sorry, jog. And now it displays the axis lag, which is the, so I think it's the amount the axis is off from where it's commanded to be, as far as I understand it. It has to do with the control loops. Because basically I believe the servo drives in this operate as in velocity mode. So the main controller unit in there sends it a command for velocity, and the controller looks at the tachometer output from the servos and adjusts the current to try to get the velocity as desired. And there's a little balance pot that adjusts the offset of that. So if that's off, it has to drive a non-zero voltage into the velocity command in order to get zero velocity. And what I think the control is looking for is the velocity command to be zero to determine that it is in the desired location. So in this case, I believe the post says the axis lag needs to be 0.0005 or less. In this case, clearly it's not. So let's just try moving it, moving the axis and see how it changes. Yeah. So we need to go trim those pots to get these down to close to zero as possible. Okay, I'm just using the camera to so I can see the axis lag values from the other side here. Let's go in here, find the pot. That's the lowest one. The problem is I don't know which axis is which here, so I'm just going to have to twiddle the pot and twiddle the pot and see which one changes. So that is the Z-axis. Okay, first pot is the Z-axis. So that was really close to zero, so now we'll do the next one. Which way do we need to turn it? It's not doing anything. Okay, just changed a whole bunch there. At least it's now approaching proper value. Try turning that farther. Let's try the Z-axis then. Or sorry, X-axis. Okay, that one's responding much better to, or was responding much better to the control. Fell off there. Okay, I moved the axis around a whole bunch more. Now it seems to be much better. I don't know what the problem was. Maybe it's the boards are happier when they warm up, or when the axes warm up and get easier to move. But it seems to work properly. Now when we go run a program, let's see if it'll work. It seems to work properly. Right now it's waiting for the tool change. If we run it, now it's, oh, no, maybe it hasn't. No, it's still one y-axis is not in position. Yeah, outside of the requirements. We've still got to play around with that a bit. If we abort the event, now it's doing its delay, I think. Let's see. Yeah, now it's running. Let's see if it stalls again. seem to work there. Yeah, I think it's a little bit marginal, needs to be adjusted slightly. This is just a quick program that cuts a little sort of rectangular shaped part with curved edges and a couple of holes. So I just quickly made that up in SolidWorks. Yep, and I got stuck again. Okay, that's about as good as I can get it for now. I'm going to have to probably take that board out and look at the pot. Either the pot is scratchy or there's something else wrong on the system. Anyway, it seems good enough we can run a proper test program. I've modified that program I've been running so far to run the spindle faster and slow the feeds down. Those were very, very fast. So let's try cutting a block of wood. This was intended to cut the end of a 2x4 into this little shape. So let's actually run that now. Okay, to load this, we need to put it in load mode. 9, it runs at 4800 baud, 7E1 I think. Start load. Now we can paste that into the terminal. Alt V. Yeah, there it goes. Okay. Let's just go look at that. It seems to have loaded. I'll just give this a dry test run first. Okay, that's a more reasonable feed rate there. Probably even slow that down a little bit. Okay, let's put a block of wood in there and see how it goes. I've set it up so that it's impossible for it to drive the cutter into the vise, so if we do have a crash, which I hope not we don't, it's only going to be into wood. A bit of vibration in the top end of the machine. I think I'll have to check for balance. and it's done. It seems to have worked perfectly. Okay, that is absolutely beautiful. First CNC part. Finish is really, really smooth. Absolutely like silk. Top is not quite so good because it's not with grain. The pockets seem to have been milled quite nicely. I'd say we have a winner. We just need to solve that axis problem. It seems to be sporadic. Like sometimes it will change by about 2 thou or so, just like a step change. So I'm wondering if there's some problem with one of the encoders or something to do with the wiring. One thing I didn't get with this machine was any manuals. So if anyone has a copy of the Tree 325 or even any of the other similar machines manuals, that would be really useful. As well, the controller, Dynapath System 20, or even a Delta System 10, Delta 10, Delta 20 would all be very useful if I could have a manual for one of those. So if anyone has any leads on that or has one, or you could make a copy for me, please let me know. I'd be willing to pay for it if you could make a copy of it. I hope you found this video on the Tree 325 interesting. It will certainly be nice to be able to make proper CNC parts now. This is going to be exciting. Anyway, stay tuned for more videos as I get this thing fully installed and running. Anyway, thanks for watching.